Okay, we're going to be solving three variable systems. What that means is we'll have three different variables, three different equations that you're going to have to solve for. When you're solving that, you're trying to find the point that they all have in common, just like a two-variable system. Okay, so the equation in your standard form would be ax plus by plus cz equals d. That's called a linear equation with three variables. The solution is called an ordered triple. So the order that it goes in is x, y, and z, so alphabetically. Example 1, we are going to verify the ordered triple 3, -1, -5 is the correct solution for that system. Okay, so this is x, 3, and then y, and then z. So to verify that, just like if you were checking, you would plug into each equation and make sure that it's true. So that's what I'm going to do. So that would be the first equation, 3 minus 1 minus 5 equals a -3. When you're working your way from left to right, that would be 2 minus 5, which does equal -3. So that one worked. Just because the first one worked doesn't mean that the others will work, so you have to plug in all three. So the second one, 2 times 3 minus 3 times a -1 plus 6 times a -5 needs to equal -21. So when you're multiplying, that would be 6 plus 3 minus 30 equals a -21. So adding from left to right, that would be 9 minus 30, which does give you a -21. So that one was also correct. Just because the first two are correct doesn't mean the third one's going to be. So you have to plug in the third one also. So you have, notice there's a missing z, but you're still plugging in for x and y. So -3 times 3 plus 5 times -1 equals a -14. That's a -9 minus 5, which does equal a -14. So we verified that that is the correct solution. On your answer, you can just write yes or no. So since they all three were correct, then it is the correct solution. So you would write yes. Okay, so now we're going to get into actually solving. Example 2, we're going to use back substitution to solve the following system. If you notice on this example, we already know z. So z equals 2. So I would need to go ahead and substitute that into that second equation so that way I'm able to solve for y. So that's 5y plus 2 equals a -3. From here, we're just getting y by itself. So subtract 2. 5y equals a -5. So y would equal a -1. We found y and we know z. To find x, the only equation that has an x is that first one. So we will use that first equation, replacing y with a -1 and replacing z with 2. So that would be x minus 3 plus 4 equals 1. So combining your like terms there, that's going to give you x plus 1 equals 1. And then you can subtract 1, so x would equal 0. So we know x, we know y, and then we were given z. So now we can write our solution. The solution is the ordered triple, so make sure you write it in that form. So x will come first, so 0, then y, -1, then z, which is 2. To check your solution, you can just plug it back into your three original equations, and it should be true for all three, if that's the correct solution. Okay, next example, we're going to use elimination. Remember with elimination, when we're solving two variable systems, we're trying to eliminate a variable so that we were able to solve for another variable. So if you look at all three of your equations, notice these bottom two equations, the y's will automatically cancel out because we have a y and a -y. So I'm going to go ahead and just rewrite those bottom two equations, and I'm going to add them together. So notice the y's cancel. 3z minus z would be 2z. 5 minus 1 would give you 4. So z would equal 2. So we found z. We need to find another variable. Notice this first one has an x, y, and z, so if we plugged in a 2 for z here, we would still have an x and a y, so that wouldn't help me solve for one of those other variables. So I'm going to either use the second or third equation, it doesn't matter which one. So y plus 3 times 2, because we're replacing z with 2, equals 5. So y plus 6 equals 5. And then you subtract, so your y would equal negative 1. So we found z, we found y, we need to find x. Notice the only equation that has an x is that top one, so that's the one that we will use. Replacing y with a negative 1 and z with a positive 2. So that would be x plus 2 plus 6 equals 9. Combining your like terms, x plus 8 equals 9. So x would equal 1. Okay, so when you're writing your solution, x comes first. So 1, then y, negative 1, and z, 2. Again, if you wanted to check your solution, plug it into all three of your equations like we did on example 1 when we were verifying that that was the correct solution. Okay, last one. If you notice on that these three equations, none of them have the same two variables, okay? So what we're gonna need to do is we're gonna need out, you can either use substitution, solve for a single variable and substitute in, or you can use elimination. I'm gonna use elimination. If you notice that we have a 3y and 3y here. So all I would need to do to one of the equations is multiply by a negative 1. So I'm gonna bring down that second equation, and I'm going to leave some space for the z because I'm missing a z. And then I'm going to multiply that last equation by a negative 1. Now, whenever you have different variables, make sure that you line them up with the corresponding variables. Okay, so that would be negative 3y plus 4z. We don't have a z, so I'm going to write it right after the y, and then equals a negative 4. So now I'm going to combine these two equations. Notice I don't have another x term, so I'm just bringing down 5x. 3y minus 3y cancels out to 0, plus 4z equals 0. So now notice that we have an x and a z in our equation. That doesn't help us solve for one of those. So what we're going to have to do is look back at our original three equations and see if there's any other equation that has just an x and a z. Notice the very top one. So I'm going to write down x plus z equals 1. I'm going to bring over the equation that I just found. And now notice that those two equations have the same two variables. So we can either use substitution or elimination. So I'm going to eliminate the x's. If I did that, I would need to multiply that top equation by negative 5. If you eliminated the z's, you would be multiplying by a negative 4. So it doesn't really matter which variable you eliminate. So when I distribute that, that's negative 5x minus 5z equals negative 5. I'm going to add those two together. Those cancel. 4z minus 5z is a negative z equals negative 5. So you would divide by negative 1 on both sides, and z would equal a positive 5. So we found z. Now we need to find y or x. It doesn't really matter which one you find next. Notice the top equation looks pretty simple, so I can plug into that. X plus z, which we just found to be 5, equals 1. So x would equal negative 4. We found x, we found z, we need to find y. So if you look back, we can't use this first one because there's no y, but we can use the second or third. I'll just use the second one. To find y. So I know x, I just found it to be negative 4. So that's negative 20 plus 3y equals 4. Add 20. You end up with 3y equals 24, so y would equal 8. So writing your solution as an ordered triple, x comes first, so -4, then your y, which is 8, and then your z, which is 5. Again, to check the solution, plug it back into all three of your original equations. It should be true for all three. So that's solving day one of 3 variable systems.